Okay, here we have operating on factors with fractional exponents, and these can look kind of nasty, and they're a wee bit tricky. Um, not, I mean, again, it's like anything in math, right? Once you learn the rule, if you can remember the rule, it's just a matter of practice. I mean, we're going to do only 4 here. If we did 20 right now, you'd probably think, I can do these in my sleep. You know, I've just done them enough times that it just wires your brain, and that's all math is, doing that over and over and over again. And where you're going to get into problems is if you're a bit shaky, like you don't overlearn this. You don't learn it to where you feel that you can do them in your sleep. So that if you see one in the test, you're kind of struggling of what's the next step, what do I do? But that's all it is. It really just comes down to learn the right rules and then practice it enough that you can do it in your sleep. So we're going to do 4 here, and hopefully by the end of these 4 you'll have the kind of pattern of how it works, and hopefully that'll stick with you. But as I say, they're a wee bit tricky. But there are 4 steps to them. Once you know the 4 steps, it's rinse and repeat. So we did exponents before, and we said with them, if they have the same bases, right? We're multiplying, they have the... do I have a pen? No. If they have the same bases and we're multiplying, what do? We can add the exponents, right? And we've done ones earlier on adding fractions. If they have the same denominator, right? Once you've found the lowest common denominator, right? And here we have the same denominator, it's 3. It's 10 over 3 times 1 over 3. Well, that's just going to be 11 over 3. We can just add the numerators. Once we have the same denominator, we can start adding or subtracting the numerators, whatever we have to do. So what we have here is, so that's going to equal 6, and we said it's 11 over 3, right? So we've added the exponents, we've taken care of step number 1. Step number 2 is the one that gets a little... because now we have to rewrite the power, right? This 11 over 3, we have to rewrite that as the sum of a whole number and a fraction. And basically you're just finding the remainder. You're just saying 3 into 9, right, goes 3. 3 9s are 9. So it would leave me 2 left over, right? So it would become 6 9 over 3 plus 2 over 3, right? This 9 and 2 add up to 11. So that's what I'm talking about and then if you look at this 9 over 3, that would give us that whole number, right? It would give us 3. So that's all you're doing. You're just finding with this numerator right here, what is the largest whole number? And then the remainder becomes the numerator of the fraction here. And I know that's maybe a wee bit much to take in if you're a wee bit shaky on math, but that's all we're doing. So now 9 over 3 will give us a whole number, right? So what we do here is we rewrite this out, right? Because now what we can have is equals, and we expand it back out again. We go from 6 to the power of 3 times 6 to the power of 2/3, right? We kind of went to one base here, and now we expand it back out and say it's 6 to the 3 2/3. Hopefully that isn't too confusing. So 6 cubed is 6 times 6 is squared is 36, and then times 6 would be 216. Alright, so 6 cubed is 216, and then we have 6 times 2/3. And the thing when you're doing fractional exponents, the way I always remember it is the denominator goes outside the radical and the numerator goes inside the radical. So what's that going to look like? It's going to give us 216, right? And we're going to have the radical bracket here, and it'll be 6. And what did we say? Denominator goes outside, so it's outside there. The numerator goes inside. That's it. And we can simplify this a wee bit more by just squaring this 6, and that would give us a final answer of 216. It's the cube root of 36. And that's it. A wee bit fiddly, but let's do the next one, and hopefully we'll start getting into some rhythm of solving these. Alright, let's do the next one. What do we do? The bases are the same. Step number 1, bases are the same, so we can add the exponents. They've given us the denominator is the same, so we know once the denominator is the same, we can just add the numerators, and we've got 3 in the first numerator and 15 in the other one, so that's going to be 18. So this is going to equal 5, and it's going to be 18 over 4, right? And we can simplify that to, because 18 and 4 can be divided by 2, so that would give us 5, and it would be 9 over 2. Alright, we've got that. Now here comes the fiddly bit. We have to get the largest, right, whole number, and then a fraction. So we've got a 9 and a 2. So 2 would go into 9 4 times, right, and leave a remainder of 1. So that means that the largest would go, 2 times 4 would give us 8, so we'd get 5, and we would get 8 over 2, and that's how we're going to get our 4, right, our largest whole number. Oh, my computer's acting up. And then we get plus that remainder is a half. And we can see, we know we're on the right tracks because our numerator is 9, and we've got 2 fractions, and the numerators add to 9, right? And our denominator is a half, it stays the same, so we know we've done it right. So that's going to become, we get our whole number at last. We get our 5 to the power of 4 plus, we separate it out again, right? Plus 5 to the power of a half. Oh, it's plus. What do I mean plus? It's multiplied. I get confused with that. Right, so we get 5 to the power of 4, right? Where did we get the 4 from? We got it from this 8 divided by 2, and then 5, it's multiplied by 5 to the power of a half. So we've got it back out again. So now we just have to solve it. We're going to get a whole number from this, and then a radical, because we've got a fraction here, we're going to get a radical part here. So I will get my calculator for 5 to the power of 4. I think I looked at it earlier. Yeah. It is 625. Good-o. So it's going to give us 625. And then we said before that the numerator goes inside, right? And the denominator goes outside. And you can see it's the 5 to the 1 is just 5. So you really, it's you just kind of convention, you don't put that in. And this 2 here, again, it's kind of convention that you don't put that in, because that's what this means. This radical is the square root of. So we've kind of said, oh, it's a square root, by putting the 2 there and then saying, oh yeah, it's a square root. So you're kind of, saying it twice, and in math you kind of don't do that. So we really wouldn't put that in. But I was just showing you how it would look. So this is our answer. It's 625 times the square root of 5, right? Hopefully that's kind of getting you into the rhythm of the thing. Now we have a division. And again, we did this before with exponents. When we divide, it's the opposite of multiplying, right? Rather than adding the exponents, we subtract them. So we're just going to be subtracting the fractions. No big whoop. Alright, so what do we get here? The bases are the same, are both 8. So we're going to get, it's going to be 8, and it's 12 divided by 7, 12 sevenths. And it's going to be minus, right? We subtract the exponents. minus 3/7. Denominators are the same, so that means we can just subtract the numerators. So it's going to give us 8 to the 9/7. So what's the largest whole number we can get? Well, it's going to be 1, right? I mean, if you understand that. I mean, I'm sorry. 7 will go into 9 one time, right? So we'll multiply 1 by 7 to get that 7, and then we get a remainder 2, right? And I say it like that because that means you'll remember to do it's 8 to the 7/7. That's just 1, right? 7/7 is just 1, but we write it like this so that we can just do our steps the way we're always doing them, and the remainder would be 2, right? So we'd have 2/7. And again, we just check. We have a 7 and a 2 in our numerator. This numerator was 9, so we know that matches up. And our denominator is 7, so this 7/7 plus 2/7 is the same as this 9/7. So we know we've got that correct. So then we just write it out. We just make this into a whole number. So it would be 8 to the power of 1, which we know is just 8, and plus 2/7. And then we rewrite it again, right? Remember, we expand it out. We get it back to having 2 bases. So it would be 8 to the power of 1 times 8 to the 2/7. We're going to get this as a whole number, and we know that's just going to be 8, right? And then how do we do this? Remember, denominator goes outside the radical sign. This goes inside. So we'd get 8, and then we can put a radical sign there. 8 there. The denominator goes outside, and the numerator goes inside. And again, we can just tidy this up by squaring 8. So we'd get 8, and it would be the 7th root of 64. So hopefully it's becoming a wee bit, clearer to you, and you're kind of seeing that the pattern isn't too bad once you've done a few of them. Right, we've got our last one here. Bases are the same, so we subtract. And here we don't have the same denominator, but you can see that 2 and 4, it's going to be pretty easy to get these the same. So we have, that's going to equal 4, and it's going to be 11/4 minus 3/2, right? So we need the same denominator, right? We've got 2 here and 4 here. We can't have that. We've got the same denominator. But all we have to do is multiply both of these by 2. If we multiply the denominator by 2 and the numerator by 2, then we're going to get the same denominator. So let me show you what that looks like. That means it's going to be 4, and then it's going to be 11/4. 3 times 2, and it would be minus. 3 times 2 is 6. 2 times 2 is 4, and now, hey, we've got the same denominator. There we go. That's what we needed. We've got the same denominator, so that means we simply can subtract the numerators. So we're going to get 4 to the power of 5/4, right? So we've taken care of all the stuff we have to do with the exponent. Now, what do? We rewrite it. We have to get the power, right, as a whole number. And then the remainder will be the fraction. So the whole number we know is, if we've got 5 and 4, the whole number is going to be 4, right? So we're going to get 4, and then it's going to be 4/4, and we're going to have a remainder of 1, right? Check it. We've got 4 and 1, that adds up to 5. So we've done the right thing, and we see here that yes, we have a whole number. 4 divided by 4 will give us 1, right? So what we get is that's going to equal 4 to the power of 1 times 4 to the power of 1/4. And then if we write it as a radical expression, we're going to get, well, 4 to the power of 1 is just 4, and then it's going to be multiplied by, and what do? We say the denominator goes outside the radical, and the numerator, the 1, goes inside the radical, but we know that 4 to the power of 1 is just 4, right? Any number to the power of 1 is just itself. So we ended up with 4 to the 4th root of 4, all the 4s. So as I say, a wee bit tricky, but hopefully what I really would hope that you see that the pattern is there, and once you know the pattern and practice it a bit, there was nothing really hard about any of it. You know, it's just a wee bit awkward, but other than that, there's nothing really to it. So hopefully the next time you see any of these in a test, you'll